we are starting with a new chapter, which is hydrogen. So first let us revise the metal activity series. The metal activity series tells you that the metal on the top is very reactive. I've made a little bit of it, and the lower metals are least reactive. So the metals which are highly reactive, when they react with water, they give out hydrogen gas. And since sodium, potassium, calcium are highly reactive, they give you an exothermic reaction. So what you see is with sodium, potassium, whatever properties, whatever observations I say are same. Think that sodium and potassium are cousins of each other. So I am giving you for sodium, reacts with water to give you NaOH and hydrogen. And what you see is, as soon as you put sodium on water, it starts skating on water and produces large amount of heat. Once the reaction is done, NaOH is formed, which is soapy to touch, meaning you touch it, you feel you are touching soap. When you react calcium with water, calcium is heavier than sodium, so it starts sinking inside water, forming calcium hydroxide, which is milky. Calcium hydroxide is like tuna you have seen in whitewashing, that looks like milky solution. So calcium hydroxide is formed plus heat is produced. Now these three metals, when they react with water, they form hydroxides. So when you are learning equations, remember that these three are making hydroxides. After that, magnesium, aluminium, zinc, iron, all these form their oxides. So I have written one equation, but if you write aluminium plus water, you will say aluminium oxide plus hydrogen. Zinc plus water, zinc oxide plus hydrogen. So as you move down, they start making their oxides. A very special reaction takes place with iron. Iron on putting in water is not going to react with cold water. Now let me get back. These three were reacting with cold water. As I am moving down, I have to provide some heat, so these are reacting with hot water. So magnesium plus hot water, aluminium plus hot water. But when we reach iron, iron needs to be red hot, meaning you heat it, it changes into a red hot iron piece, and water also has to be changed into steam. So that means the reaction rate has become so slow that you need to provide so much energy. So in the first three reactions, heat was being produced. Here we are giving heat. So red hot iron reacts with steam to give Fe3O4, also known as magnetic iron oxide or triferric tetraoxide. The metals below do not react with water very easily. In fact, the lower ones do not react. Lead and copper under strenuous conditions can react. Now to prepare hydrogen, we can use acids. Now as I just told you that the metals on the top are highly reactive and reactions are exothermic. So we do not like to use these metals to make hydrogen. Hydrogen itself is an explosive gas, combines with oxygen of the air and explodes. So you have to be very careful when you want to make hydrogen in the lab. So when you want to make hydrogen, these metals cannot be used because they are very reactive. Metals in the center are moderate. That means their reaction is not too fast, not too slow. But out of them, magnesium and aluminium are highly expensive metals. So if they are expensive, we avoid using these two. Then zinc and iron can be the metals which can be used to make hydrogen. So moderate metals are used. Again, these are too slow, so it will take ages in the lab to make hydrogen. So we do not use these. These metals, which are moderate metals, are used with any acid. It can be dilute sulfuric acid or it can be with dilute HCl. So any acid, all acids, property of the acid is that the acid reacts with metals to give out hydrogen gas. And the chosen, why do we choose zinc is because zinc and iron both are moderate metals. Out of them, zinc that is used is called granulated zinc. Now granulated zinc contains some impurities, and those impurities help in making hydrogen fast because these impurities act as catalyst. So the best choice that we use to make hydrogen is zinc by using dilute sulfuric acid, which gives hydrogen gas. To prepare hydrogen in the lab, we use, as I said, granulated zinc, and any acid can be used. It can be dilute HCl or H2SO4. So I've taken one bottle which has two openings. It is called a Wolff's bottle. So from one side, from this point, we add some acid. So acid is added from here. So it could be dilute HCl or H2SO4. Let's put inside here. Granulated zinc is here. Now the gas rises up because hydrogen is a light gas. So it starts rising up. And when it rises, it now goes into my flask, which is kept upside down in a trough of water. Why have we done this is because the gas is light, it will rise up. The gas is not soluble in water, so we can pass it through water. The gas is highly explosive, I just told you. So if I don't put water in it, it will combine with oxygen to explode. So it's not done that way. It is passed through water. Now water is moving down, the gas is moving up. As you see from here, so that is known as downward displacement of water. You are displacing water in the downward direction. So when you are displacing water in the downward direction, you will say it is downward displacement of water. Now see the next one. In this, the jar has been kept straight and the gas is moving out. If I keep a jar straight which has nothing, it means it still contains air. And supposing the gas is falling inside, this is the gas which is falling inside the gas jar, the gas must be heavy. So if the gas is heavy, we use this method in some gases. So if the gas is heavy, it will fall down into the gas jar and air will move out. So when air moves out, we call it upward displacement of air. See the direction of what movement are you doing. In this case, you are moving water, here you are moving air. So the reason why these methods are used in different gases is depending upon the properties of the gas. If the gas is soluble in water, I cannot use this method because how will I get the gas if the gas starts dissolving inside water? In that case, I'll have to use that method. Plus, if the gas is heavy, we will use this. If the gas is light, we will use this method.